Okay, so starting with 7 is the first question I heard. These right here. Okay, so the first one is a 30, 60, 90. If you remember the pattern, the longer side is here, the shorter, it's x squared to 3, x and 2x. So you could fill in the numbers on this, or you could just use the pattern, honestly. Okay. This would be 3 and 3 square roots of 3. But the secant of 60 is from this angle, the 60 up here. What is the definition of secant most of you are comfortable with? Okay, it is the reciprocal of cosine, so it's hypotenuse over adjacent. So it would be 6 over 3 or 2. We good on that one? And cotangent is the reciprocal of tangent. So instead of opposite over adjacent, it's adjacent over opposite. So 3 over 3 square roots of 3 is going to become 1 over the square root of 3, or, okay. And it will work the same if you use this triangle, okay? The x's will always divide out. This is a 1. All right, 45, 45. This would be 5, 5, and what? Or x, x, and x square roots of 2 on the hypotenuse. Whoops, that's supposed to be 5. All right, so the sine. Guys, if you have the sine of 45 memorized, it shouldn't matter what the picture looks like. What is the sine of 45 always? Square root of 2 over 2. Right? It's the y value of the ordered pair from the unit circle. If you did it from here, from this picture, you would have opposite over hypotenuse, so you'd have 5 over 5 square roots of 2, which would simplify to 1 over the square root of 2, which would become square root of 2 over 2. Okay, the secant is what? Okay, so it's hypotenuse over adjacent. Hypotenuse is 5 square roots of 2. Like is this, so we get square root of 2. Any questions? All right, this one somebody asked about, and this is a good one to ask about. It does not say it's in any particular quadrant because we're still in the section on just plain old right triangles, okay? So the secant is the flip of cosine, so this is hypotenuse over adjacent. If I put an 11 here and a 9 here, I need to do Pythagorean theorem. 9 squared plus whatever you want to call that side squared equals 11 squared. I think it's 40, is that right, guys? And so x is the square root of 40, or the square root of 4 times the square root of 10, 2 square roots of 10. All right, so these aren't pretty. It says find the cosecant. Cosecant is what? Hypotenuse over opposite. So it's 11 over 2 square roots of 10, which is 11 square roots of 10 over what? Two square roots of 10 times square root of 10 would become what? Times 2 is? Okay, I thought somebody said 11. I'm sorry. All right. It could ask you, it does ask you to find more than one, by the way. It might also say find the tangent or the cotangent or something, okay? Once you've drawn it, you're good. All right. By the way, on the quiz tomorrow. You do get a unit circle. You only get the front side of the unit circle, though. Okay? Meaning it doesn't have the definition of secant as 1 over cosine. You got to know those. Okay. This one says cotangent is, ooh, ick. So if I have a right triangle, I would have cheated. I would have said this is really 8 over the square root of 17 that's been rationalized. And does anybody else see that? Because that would help us a lot, but we can leave it the way it is. Cotangent is adjacent over opposite. So if I put my angle down here, I have 8 square roots of 17 over 17. If I go to do Pythagorean theorem, this is 289. This is 8 squared, which is 64, times the square root of 17 squared, which is just 17, right? How am I doing? So far I haven't messed it up. So what's 64 times 17 plus 289? (64 times 17 is 1088 plus 289, 1377. Did someone else get that? Okay. Does 17 or 17 squared go in there? Oh, actually it's 81 times 17, right? Nine square roots of 17 goes here. All right, it says secant, which would be hypotenuse over adjacent. So 9 square roots of 17 over 8 square roots of 17 would have been 9/8 for the secant. Can you do those 10, guys, even if they're miserable? There may be some practice assigned. Right up here, it says these were off of worksheet 2, 3, 4, and the special right triangle worksheet, okay? It very clearly lists where to find practice on that and notes. All right, what else? 29 through 31. Okay. Find the reference angle. If it's in radians, you have to answer in radians. Anybody have a guess here? I'm guessing the reference angle is pi over 4. But most of you would want to change that to degrees probably, right? So if you multiply by 180 over pi, you get 675, anybody? Okay, is that the reference angle? Definition of a reference angle is, well, yes, that's what you're gonna do to this. But the definition of a reference angle is it is an acute angle made with the x-axis and it's always positive. So if I take a 360 off this, like Martin said, I'm down to 315. So 315 is here, all the way around to there. And the angle it makes here is 45 to the x-axis. So 45 degrees is the reference angle in degrees, but because it started in radians, you have to switch it back to pi over 4. Negative 167. You could draw it. It would be here. So what do I need it to get to this way? Yeah, the 180 line. So if you just did 180 minus 167, because you need a positive answer, is that 13? So the reference angle is 13 degrees. Remember, it's got to be positive. This one, if you have a negative, you also could just keep adding 360 until it became positive. If you add that, I think you get 15, don't you? So the reference angle in here is just 15 degrees again. Do you need one from every quadrant, guys? What if it was 102 degree angle? What's the reference angle? Is it 12? Nope. It's got to be to the x-axis, remember? Not the y. So it's 180 minus 102, which would be 78. Everybody okay? Is that enough of those reference angles? Do you need me to do another one in radians or not? Okay, just switch it to degrees and then back to radians will be fine. All right, here's a picture of a unit circle, which you will have for doing these. I think this is why Xavier asked for these questions. You should be able to quickly go through and use your unit circle to find these values. What is the helpful piece of information? The first one is the second one is the sine. As long as it's a unit circle, you don't have to worry about anything else because the radius is 1. And tangent is, yes, or no, it's, yes, it's like slope, remember? Yep. All right, so 7 pi over 6, you just find it on your unit circle. It's right down here, and it wanted sine, so you write down what? Negative 1/2. Yep, watch your signs. Okay, for number 20, cotangent, negative 5 pi over 6. I usually look and go, okay, well, 5 pi over 6 was around 150 that way. So a negative 1 is going to be to here. So this is where I'm looking. Everybody get what I'm saying with the symmetry? And then it wants the cotangent, which is x over y. So it's negative square root of 3 over negative 1. Because we talked about that the denominators will always go away, right? Positive square root of 3, yep. Okay, sine of negative 180, you should be able to do without the unit circle. That's here, and so you went left 1 and up 0, so the sine is 0. The cosecant, that's actually a good thing to do, is to write the ordered pair next to each one, because then I can tell if you were in the right spot. Okay, cosecant is down here. It's a pi over 4 is a 45, and we went negative, so it's this way. So the ordered pair, somebody, without looking, anybody? The y value is, right? Because we went right and down to be in that quadrant. So cosecant is the reciprocal of sine. So, and some of you have this memorized, but if you rationalize this disaster, you get 2 square roots of 2 over 2, or just negative square root of 2. That's negative. Sorry if it doesn't look like it. There we go. All right. Negative 840. I would add some 360s, like 2 of them, at least. You could even keep going until it's positive. That would give me a negative 120. Which is down here at a 60 degree reference angle, which is over a little, down a lot. So it's negative 1/2 negative square root of 3 over 2. That's what I'm thinking. If you had added 3 360s, what would you get? Negative 840 plus 360, 3 times is a positive 240. So you're down here. Did I write it down correctly? I think I did. All right, so the sign is just the y value. All right. What is the sign at any pi over 4 that's odd? Square root of 2 over 2, right? Just a matter of the sign. Like, is it positive or negative? 5 pi over 4s would be 4 pi over 4s. 5 pi over 4 would be in this quadrant. So everything is negative, yep, except tangent and cotangent. Okay, cosecant at 0. Well, the ordered pair there is right 1 and up 0. Be really careful, though. These are the ones everybody gets wrong. Cosecant is the reciprocal of the 0, right? The sign. So 1 over 0, what are you going to write? Undefined. Cotangent 840. When we subtracted 360s, 840 minus 360 3 times, we got, oh, we only need to subtract 2, right? So we want it to be positive. So we do minus 720. We have the cotangent of negative or positive 120. Somebody else get that because I'm struggling here. Okay, the cotangent of 120. 120 is over here. It's a 60-degree reference angle, which means it's up further. So I'm thinking that's the ordered pair. Is somebody checking? And it's left and up. Okay, cotangent is what? Cosine over sine, which in this case would be negative 1 over the square root of 3. Everybody good that I left the denominators off? Because remember, it's negative 1/2 divided by square root of 3 over 2, which is negative 1/2 times 2 over square root of 3, which is going to make those go away. All right, and then if you multiply by square root of 3 over 3, get negative square root of 3 over 3. Feeling good? Take your time, do a good job on that section. There's a lot of questions on that section. What else? I'm going to do one of these or 2 of these. It says find the exact value of the 5 trig functions. On the quiz, you don't have to. I ask you like one of them. Okay? And what quadrant the angle is in. If the tangent is positive, all students take calculus. It could be in this quadrant or this quadrant, right? It's the only place the tangent is positive, right there. Then what does this mean? Because students who don't know their greater than less thans really struggle here. What does that say? Positive, greater than 0. And cosine is greater than 0, also positive. So what quadrant am I in? Okay, so that's part of the question. It will ask what quadrant you are in, and you can write either a Roman numeral 1 or the number 1, I don't care. And then the tangent is 2, means from this angle, tangent is 2 over 1 or opposite over adjacent. If we do Pythagorean theorem, what are we going to get? 1 squared plus 2 squared equals, not on a good day, square root of 5. Everybody good? So, I don't know, give me the secant. Would be hypotenuse over adjacent. So square root of 5 over 1 or square root of 5. Do I need to do all 6 of them or you get the idea? I can do more. You okay? Just my biggest concern is that you watch the signs closely. So you want me to draw the other 2 at least so we can figure out the quadrant? You do not, but you do have to state what quadrant it's in. Okay? So this one says cosecant is 2, which is positive. Sine is greater than 0, which is positive. And cosine is less than 0, which is negative. So what quadrant is that in? All students take calculus. Okay, cosine is positive here, so that one's out, that one's out, that one's out. The sine is positive here, and the cosine is negative. So this is negative, this is positive, and the hypotenuse is always positive. All right, cosecant is 2 over 1, which means what? Yes, okay, so the sine is 1 over 2, which would be opposite over hypotenuse. So the 1 goes here, 2 goes here. What goes here then? Leg squared plus other leg squared equals hypotenuse squared. It's not square root of 5 this time, because it's a leg. It's not square root of 2. 4 minus 1 is... We're going to be careful? Because I'm getting a lot of wrong answers. All right, so I don't know. What if it asks for cotangent? Negative square root of 3 over 1, or negative square root of 3. By the way, that was quadrant 2. If you want me to find more functions, let me know, but what is this telling us, guys? The sine is, that's a negative, and the cosine is positive. All students take calculus. Where's the cosine positive and the sine negative? Yes. So we are in quadrant 4, where opposite over hypotenuse from this angle up here that I drew badly is negative 1 over 5. Now, some missing x value here. It actually is an x because it's over. X squared plus negative 1 squared is got to be positive 1, right, guys? So minus, this is still came out a positive 1, so we're going to subtract. It's going to be 24. Everybody good? Did I go too fast? You okay? This is a positive 1. So we're subtracting it over here. Okay. 2 square roots of 6, anybody? Positive or negative? As you went to the right, that's positive. Okay. What if it asked for the secant? Would it be hypotenuse over adjacent cosine, right? Secant flipped over as cosine. Square root of 6, square root of 6 would be 5 square roots of 6 over 12. Anything else? Do we need to review where those buttons are on the calculator to change degrees, minutes, and seconds? What about angular linear velocity? What time are we done? 30? Okay, you only got about 2 minutes till I got to pass out the quiz. The unit circle quiz. Okay. 213.395, just type it in your calculator. Anybody remember where it is? It's second apps to get the angle menu, and then it's choice 4, degrees, minutes, and seconds. And then you can do the other one a couple different ways. You could just cursor up, which was a good idea that Martin had, and then type over 79, 3, and 45 in there so that it changes it. $79, 3, and 45, was it? 79.0625. I always go 79 plus what? 3/60ths plus 45 3600ths, because that's how many seconds. Otherwise, the buttons are under the math. Oops. Under the app here are the degrees and minutes, and then the second one is over here, alpha plus. What about this one? Okay, what is this? Radius is 4 inches. It's turning 1750 revolutions per minute. What do you have to do with revolutions? Say 1 revolution is 2 pi radians. Don't lose the pi. Okay, now you have radians per minute. They want feet per minute. Well, first of all, you got to multiply by the 4 down here, right? Because it wants a linear, so you have to take the angular, which we just made this an angular. All of this right here. Multiply by the radius, which is 4 inches. But they want feet, so you're going to say 12 inches is 1 foot. So you're going to type 1750 times 2 times pi times 4 and divide it by 12. Don't forget to type the pi in. Somebody always does. I got 3665.2. Anybody? Feet per minute. Are we good? Okay. Stop.